In this paper, we are looking at June 2025, Mathematics Paper 1. The first question says, express 4,560 in standard form. So you should know that standard form needs us to express in the form a times 10 to the power n, where a is any number between 1 and 10, and n is any integer, positive or negative, or 0. Because of this, it seems that what we can do is we need to move the comma some certain places, either to the left or to the right. So since our comma is after 0 there, you notice that what we need to do is to move the comma 3 places to the left so that we can have a number between 1 and 10, so that our number becomes 4.560 times 10. And then the number of places that we move, it becomes our power. A thing to note is that if we move the decimal place to the left, our power of 10 is positive, and if we move the decimal place to the right, the power of 10 is negative. Then we write our answer in the given space, 4.560 times 10 to the power 3. Moving on to the second part of question 1, it says, it is given that this number 2 times 10 to the power 3 times 1 times 10 to the power that is equals to 2013.05, where x and y are integers. Find the value of x and y and the value of y. So here you can see that the first two numbers can be expressed as normal numbers. So 2 times 10 to the power 3 is the same as 2 times 1000, which is the same or equal to 2000. Then you see that the next number there, 1 times 10 to the power 1 is the same as just 1 times 10, which is equals to 10. And if we add the two numbers, 2000 plus 10, we get 2010. Right, so we're going somewhere now. Now we subtract this number 2010 from the other normal number 2013.05. So we simply align the numbers like that. 2013.05 minus 2010.00. Then we get our answer. So it's simple subtraction. 5 minus 0, you get 5. And 0 minus 0, you get 0. 3 minus 0, you get 3. 1 minus 1, you get 0, 0, 0. So we subtract, we get 3.05 there. Now, after that, what we now need to do is equate the remaining numbers. We're going to use a certain kind of logic here. You can see here that 3 times 10 to the power x plus 5 times 10 to the power y is equals to 3.05. The logic which we are going to use here is that it must imply from the two numbers that we have, it must mean that 3 times 10 to the power x must be equal to 3, and 5 times 10 to the power y must be equal to 0.05. Now, why are we using this logic? We're using this logic because if we look at the numbers, they seem to be related somehow. So these are the kinds of patterns and trends or relationships which you are looking out for. Because in mathematics, the whole idea is to solve problems. And when you encounter problems like this, you must be able to identify patterns or relationships. So here we are going to use the logic that 3 times 10 to the power x is equals to 3, and 5 times 10 to the power y is equals to 0.05. Now we've broken down our number 3.05 to 3 times 10 to the power x plus 5 times 10 to the power y. Now we're just going to solve it simply using one of two methods. If you want, you can break down the 3 and express it in a normal form. 3 can be equal to 3 times 10 to the power 0 because any number to the power 0 is 1. And 0.05 is equals to 5 times 10 to the power minus 2. Okay, so in this case now, you can see that it's already clear. We can just now equate the powers of our two answers. or two sides. 3 times 10 to the power x is equals to 3 times 10 to the power 0. Since 3 is equals to 3, 10 is equals to 10, it must also imply that x is equals to 0. Or, in the second one, 5 times 10 to the power y is equals to 5 times 10 to the power minus 2. That must also mean that if 5 is equals to 5 and 10 is equals to 10, then y is equals to minus 2. The second method which we can use is to use normal division. We already said that 3 times 10 to the power x is equals to 3, and 5 times 10 to the power y is equals to 0.05. So what we are going to do here is we are going to write it in this way. I'm going to write the answer first. So we've determined that x is equals to 0 and y is equals to minus 2. Okay. The second method that I was talking about is this one. We have our numbers 3 times 10 to the power x and 5 times 10 to the power y being equated to 3 and 0.05 respectively, right? So what we can do is simply divide by 3 both sides for the first one. When we divide by 3, we're going to get 3 divided by 3 is 1. 10 to the power x is equals to 1. And we know that from the rule of indices, any number 1 can be expressed as x to the power 0. So any number can be expressed to the power 0. So in this case, we can say 1 is equals to 10 to the power 0, which is going to give us 1. Since the bases are equal, then the powers should also be equal. We use again the same method in the second one. 5 times 10 to the power y is equals to 0.05. So we divide both sides by 5, divide by 5 both sides. So here we remain with 10 to the power y is equals to 0.01, because if we divide 0.05 by 5, we get 0.01. Now, we're going to express 0.01 as a power of 10. It is the same as 10 to the power minus 2. Again, we get to 10 to the power y is equals to 10 to the power minus 2, and hence it is equals to y is equals to minus 2. Moving on to question number 2. In the diagram, you are given PLQ, which is a straight line. Line M is parallel to line NR. The line LM bisects QLN, the angle, because there's a Chinese head there, so it means that it's an angle. And you are given also that NLM, the angle, is equals to 50 degrees. The angle PLN is equals to X degrees, and the angle RNS equals to Y degrees. Now, this is very important information which you must use to your advantage to solve this problem. You've been told that QLN is an angle which is bisected by LM. So LM then, if it bisects QLN, then it must mean that the angle that's formed between there, which is a 50 degrees angle, the other part is also a 50 degree angle. So to use this reasoning, we can write it in this way. Since NLM is equals to 50 degrees, it must also imply that QLN is equals to 2 times NLM. Now, when we've done this, then it's very simple. So QLN is 2 times NLM, so it's 2 times 50 degrees, which gives us 100 degrees. Now, we know that angles in a straight line add up to 180 degrees. So what we are simply going to do to find x, we're going to say 180 degrees of the angles in a straight line, subtract 100 degrees of the angle QLN. That means 180 minus 100 gives us 100 degrees. Now, this is a very simple way to solve it, right? And you do not need to look too far to get answers for this one. So our answer there to find x, which is equals to PLN, is simply 180 minus 80, giving us 80 degrees. Okay, so x is equals to 80. The next number is asking us to find the value of y. Since you can tell here that since we've been given that LM and NR are parallel, then it must mean that the angles formed by that line there, LS, is the same, because we can say that they are alternate interior angles, or we can say that they are corresponding angles. The more common term is corresponding angles. All right, so alternate interior angles or corresponding angles. So this must mean that y is equals to 50 degrees. All right, fine. And then you always write the reason. So whenever you are doing geometry like this, finding angles and sides, etc., you must always give a reason why. That is the explanation to solidify your answer. So we said here that y is equals to 50 degrees because they are alternate interior angles, or you can simply say y is equals to 50 degrees because they are corresponding angles. Always remember to put your answer in the given space, and don't forget to put the reason, because answers do not just come from the sky. You don't just download from the cloud, right? Okay, so we put our answer there. X is equals to 50 degrees. Don't forget to put the correct units. All right, let's move on to the next one. Here we also put our answer 80 degrees, like we had calculated earlier on. Okay, so that our work looks neat. Question 3 says, the temperature reading in degrees Celsius at noon over a period of 6 days were 30, 29, x, 31, 30, 32. The mean temperature was given. Calculate the value of x. So the mean temperature for the 6 days was that. So to find the value of x, you just add all the temperatures, divide by the number of days, and then give the mean. So here, simple. We now multiply both sides by 6 so that we eliminate the fraction part. So multiply both sides by 6. So if we multiply the left side by 6, we're just going to cross out the fraction part, the denominator. And if we multiply the right part by 6, we're going to get a certain number. So the left side will be remaining with these numbers: 30 plus 29 plus x plus 31 plus 30 plus 32 being equal to 30.5 times 6. So now let's multiply. 6 times 5 gives us 30, 0 carry 3, 6 times 0, 0 plus 3, 3, 6 times 3, 18. So the total temperature which we get here is 183.0. Then next we are going to add those other numbers so that we add like terms together and keep the unlike terms together. So here we add 30 plus 31, 29 plus 31, that's 60, 30 plus 30, that's another 60, plus 32, that gives us 152, plus x equals to 183. And x is equals to 183 minus 152. We just subtract 152 from both sides, and then we get x is equals to 31 degrees Celsius. So because x is a temperature, we need to put units. X equals to 31 degrees Celsius. 4a. Solve the inequality x minus 8 is greater than 4x plus 1. Again, when we are solving inequalities or equations, the simplest way is to bring all like terms together and unlike terms together. So we can bring terms with x on one side, terms without x on the other side of the inequality sign there. So since 4x seems to be greater than x, it's better to bring the terms with x on the right side, all right, and then the terms without x on the left side. Now we're going to remain with, if we subtract x from both sides, we're going to have minus 1 minus 8, because we're going to subtract 1 from both sides, is greater than 4x minus x. Then here we're going to do a normal subtraction. Minus 1 minus 8 gives us minus 9, and so it will be minus 9 is greater than 4x minus x gives us 3x. Still, we can simplify this because there's some commonality between minus 9 and 3x. We divide both sides by 3. 3 into minus 9 gives us minus 3. 3 into 3x just gives us x. So minus 3 is greater than x. And this can alternatively be rewritten as x is less than minus 3. So if minus 3 is greater than x, it means that x is less than minus 3. All right, we write our answer there. Second part says represent the solution to A there on a number line. Now, we're just going to draw a sufficiently long number line with the X labeled there, and put maybe just 3 or 4 arbitrary values. So we're going to put 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4. Maybe let's just put another one, maybe minus 5, so that we can show that the number continues. Now, we say that the value of X is less than minus 3. So we're going to put an empty circle, draw a line, and put an arrow to show that the solution goes up to negative infinity, because we've just been told that X is less than minus 3. So a general tip which I can give here is that if you notice well, I put an empty circle. So when you are solving problems with inequalities, you should take note of this. If you have the inequality sign without a line below it for the equal to show that it's equal to or less than or equal to or greater than, you put an empty circle. So that empty circle there signifies that the point is not included in the set. Because here we said that minus 3 is less than X, is greater than X. So it means that that minus 3 is not included, okay? But if the number was included, let's say, for example, if it was X is less than or equal to minus 3, then we'd put a full or shaded circle, which means that that point which we are looking at is also included, okay? If you want more on this, there's a whole lesson. If you check on the videos, I'll put a link in the description so that you can go through the numbers section and appreciate more of this. Let's move on to question 5. Evaluate this number 0.2 times 0.35. So there are many methods which you can do this. I find that the simplest method for me is to just multiply these two numbers together normally, just 2 times 35, and then you add in the total number of decimal points of the two numbers, okay? So you multiply 2 times 35, then after you finish multiplying, you count how many decimal places there are. 0.2 as 1 decimal place, 0.35 as 2 decimal places. So the total number of decimal places will be equals to 3. Will be equal to 3. So then your answer after you multiply, you move now the decimal point from the end of that answer which you have to the left, so that you can get your answer. Because here you are multiplying decimals. So if you multiply 2 decimals, you're going to get a number which is smaller than both of the decimals, okay? In this case, if you're multiplying numbers less than 1, decimals of numbers less than 1, then obviously the answer is going to be less than, far less than both of the two answers. So here, we're going to multiply 2 times 35. So 2 times 35 gives us 70. Then we're going to count the total number of places. That's 1, 2, 3. So since there are 3 decimal places, we're going to move the decimal point from 70, 3 places going to the left. Okay, so 1, 2, 3. So our final answer is going to be 0.070. Obviously, you can do it in other ways. You can just multiply it as it is in column form, and after you multiply it in column form, again, just count the number of decimal places, and it will still give you the same answer, 0.070. Moving on to part B, 1 and 2 over 5 divided by 1 and 2 over 3. So when you encounter mixed numbers like this, the first thing which you need to do is to convert both of them to improper fractions. Okay? Improper fraction. An improper fraction is a number in which, or is a fraction in which the numerator is bigger than the denominator. So you convert these mixed numbers to improper fractions. So both the first and the second one should be converted to improper fractions. After you've done that, then you need to invert the one of the fractions, either the first one or the second one, preferably the second one, so that you don't confuse yourself. Just invert the second fraction, okay, so that the numerator becomes the denominator and the denominator becomes the numerator. That's what we mean by invert one of the fractions there. So let's do this. The first one is saying 1 and 2 over 5. So to convert this mixed number into an improper fraction, we multiply the whole number by the denominator, then we add the numerator. So that's 1 times 5, then we add 2. So 1 times 5, that's 5 plus 2, that's 7, divided over 5, divided by 1 times 3, that's 3 plus 2, that's 5. Then we maintain the denominator, 5 over 3. Next section, we invert one of the fractions. So 7 over 5 multiplied by 3 over 5. Then it's now simple. We multiply the numerators together and then the denominators together, since there are no common factors between the numerators and the denominators for both fractions. Okay, so now it's 7 times 3, which gives us 21. 5 times 5 gives us 25. There are no common factors between 21 and 25, so it means that 21 over 25 is in its lowest terms. All right. Next part, C. Find the square root of 0.0081. What you can notice there is that 0.0081 is a decimal which can be converted to a proper fraction. Okay. I'm sure you must have come across this section. This is the first topic of numbers. So you must be able to convert normal numbers into decimals, into fractions, and into percentages. Again, the link for this, the link for the video for numbers, learning about numbers, where it's explained in more detail, is found in the description. I'll also pin a comment to link you to the playlist where you can find these problems. So let's convert 0.0081 to a proper fraction. So 0.0081, we can put a 1 where there's a comma and count the number of decimal points after the 1 there. So that's 1, 2, 3, 4. So it means that 1 has got 4 zeros. So 0.0081 can be written as 81 over 10,000. Now, another rule when we are working with these numbers is that if we are looking for the square root of a number, a over b, it is the same as saying the square root of a divided by the square root of b. That's just a rule which you have to know. You must remember this always. The square root of a quotient, which is a result of having two numbers dividing each other, one as a numerator, which is the number on top, and one as a denominator, which is the number at the bottom. Now, we have the rule of square roots, which I was talking about. If you are finding the square root of a quotient, it is the same as saying finding the square root of the individual numbers in that fraction, right? So here we need to find the square root of 81, which is equals to 9, and the square root of 10,000 is equals to 100. So square root of that number 0.0081 is the same as 9 over 100. We can also express it as a decimal, which is equals to 0.09. Okay, so 0.09 there will be your answer. So you can leave it in this form, or you can leave it as a normal fraction, no problem. Question 6. The temperature readings at 9 a.m. and 16 later were -3 and 18 degrees respectively. It is assumed that the temperature was rising at a steady rate. So it means that the rate of increase was steady. So if it's increasing at 1 degree per hour or per minute, is the same for the whole range. So find the temperature range. To find the range, very simple. Maximum temperature minus minimum temperature. The maximum is 18 degrees Celsius. The minimum is -3. So 18 minus -3. Since these are directed numbers, it's the same as 18 plus 3, which is equals to 21 degrees Celsius. That's the temperature range. The range is the difference between the maximum and the minimum. Always don't forget to put units. Now, the next question says, find the rate of temperature change per hour Okay, so the rate means that we are looking, there's a time factor, and the time period which you've been given is per hour. So the rate of temperature change per hour. So to find the rate of temperature change per hour, we need to calculate how much time elapsed from 9 a.m. to 16 p.m., which is simply 16 minus 9, giving us 7 hours. Then to calculate the rate, we are going to say the change in temperature, which is the range, divided by the total time, or change in time, which is what we calculated there. So we're going to take our range, which we already calculated, which is the temperature range, and we've already calculated, we've seen that it is 21, and then we already calculated the time, we've seen that it is 7. So temperature change over time is 21 degrees over 7 hours. So we divide 21 by 7, we're going to find 3 degrees Celsius per hour. Okay, so don't forget to put the units 3 degrees Celsius per hour. So it means that the temperature was increasing steadily with a rate of 3 degrees Celsius per hour. Find the temperature at 1300 hours. Now, since we've been given the start time and the finish time and the rate at which the temperature was steadily changing, don't forget that steadily part. So it means that we can simply find the difference between the start time and this given time and just multiply, or we can do the reverse from the finish time minus this time and multiply. Again, we'll still get the same answer. Okay, so how do we do it? Let's put that into writing. So 13 hours from the start time, which is 900 hours in the morning, is 4 hours. Okay, so that's 13 hours is equal to 4 hours from 9 hours, or 9 o'clock in the morning. Or we can also say 13 hours is how many hours from before 16. So it is 3 hours before 16. Okay, so that will help us to calculate, and the answer will be the same. All right, so now let's calculate using the first method, starting from 9 hours. So 4 hours times 3 degrees per hour to get the temperature change. That's going to give us 12 degrees Celsius. Okay, then we add the 12 degrees Celsius to the initial temperature at 9, which was equals to minus 3. So we're going to say 12 plus minus 3 degrees Celsius, and then we're going to get 9 degrees Celsius. All right, let's look at the second method which we can use. We said it's 3 hours before 16 hours. All right, so if it's 3 hours before 16, we're going to say 3 hours before 16 times 3 degrees per hour, and we're going to get 9 degrees. But since it is before, it means that we are going to subtract it. Okay, it's different now. In the first instance, we're moving in the forward direction. In this case, we're moving backwards from the finish time. So we're going to subtract 18 minus 9 degrees Celsius, and we'll still get the same answer, 9 degrees Celsius. So you see, it doesn't really matter which direction you take. As long as you know what you are doing, you arrive at the same answer using an alternative form of the method. Question 7a says, round off 148.32 to the nearest 10. So we need to write the place values. The first one is hundreds, the 4 is tens, the 8 is units, 3 is tenths, L is hundreds, 1 over 100 and 1 over 10. So in order to round tens, we must look at units. Okay, so since the unit is 8, it means that it is greater than 5, and therefore we're going to add 1 on the tens value, so that will become a 5. So that number will become 150. We don't need to put the decimal points because we're rounding to the nearest 10. All right, so our answer there is 150. Moving on to part B, estimate 179.35 times 0.0496 by first expressing each of the numbers to one significant figure. So you're first supposed to round each of the numbers to one significant figure and then do the multiplication. All right. So what we need to know, what we should take note of here is firstly understanding what significant figures are. A significant figure is the first non-zero digit from the left of any given number. So in this case, you can see that we've been given 179.35. That is, the first one there is already significant because it is non-zero. In the second number, we are given 0.0496. So the first 0 is non-significant, the second 0 is non-significant, the third number there, the 4, is the significant figure. However, a thing to note about these numbers is that if a 0 occurs between two significant figures, then that 0 is also significant. What do I mean? If you are given a number, let's say for example, if it was 109, then that 0 there would be a significant figure because it is occurring between 1, which is significant, and the 9, which is also significant. However, if a 0 is the starting number from the left, then it is non-significant. Okay? Like they say, your company determines who you are, right? So the 0 is significant if it is only between two significant figures. If it is the first figure from the left, it is non-significant. Now we need to round our numbers. The second significant figure there is 7 in the first one, so it's greater than 5. We add 1 to the 1. The first number becomes 200. In the second number, the 4 is the first significant figure, the 9 is the second significant figure. Since 9 is greater than 5, we add 1 to the 4 and it becomes 0.05. Okay? So now, after we've done this, we just simply multiply because it says estimate. We are estimating, meaning that we're going to give a rough figure. So 200 times 0.05, we can use many methods to multiply this. You can just multiply 200 by 5 divided by, then the answer, you move a decimal place 2 places to the left. Or you can convert 0.05 to a fraction and then you multiply. You still get the same answer, you get 10. All right, like I said, the second method, we can do it in this way: 200 times 5 over 1, put 2 zeros there, 5 over 100, you divide by 100 both numbers, and then you get 5 times 2, giving you the same answer, 10. The good thing is that with mathematics, you must show all working, and all your working will result in marks, part marks for each step. A solid cuboid measuring 5 by 2 by x measures 5 by 2 by x. Give an expression in terms of x for the total surface area of the cuboid. In my experience and opinion, the most important thing or the most helpful thing here would be to draw the cuboid so that you can have a visual representation of what you are doing. When you are working with shapes, it's always better to draw them first. When you draw them, it is easier to now solve the problems because you can actually see what you're doing, where you are going, and if you make a mistake, you can kind of like retrace your steps. This is why now, when you show your working, if you are not satisfied with the answer, or if the marker is going through your work, they can check where you've lost it, where you made a mistake, what you could have done, and perhaps award you marks for maybe error carried forward or something. Now, we've drawn our cuboid, 5 times 2 times x. We need to find an expression for the total surface area. So what we need to do, you can tell that from the way the shape is arranged, the cuboid has got 2 sides, 2 faces which are equal for each slot. Like for example, for the first one, you can have the face which is facing us has got an equal face which is behind. The face to the right has got another one which is to the left, and the face on top has got another one which is equal to it at the bottom. So what we're simply going to do is we're going to have 2 multiplied by 5 by 2, which is the bottom and top. Then 2 multiplied by 2 and x, which is the side, the left and the right. And then we're going to have 5 multiplied by x, which is the front and back. That's very simple, right? Now, let's quickly do this. 5 times x is equals to 5x multiplied by 2. That gives us 10x. Right, then the next one, 2 multiplied by x, that gives us 2x multiplied by 2, which will give us 4x. And then 5 multiplied by 2, which is the bottom and top, giving us 10. So now we simply need to expand it. 2 times 5x, that's 10x. 2 times 2x, that's 4x. 2 times 10, that's 20. Then this is our expression for the total surface area. Now since 10x and 4x are like terms, we can add them and get 14x plus 20. So 14x plus 20 is our expression for the total surface area of this cuboid. Now, you are not required to factorize it, okay? So even if you leave it like this, it will still be correct, 14x plus 20. Of course, you can choose to factorize it. You can factorize 2, and then you remain with 7x plus 10. That's the expression for the total surface area. The next one says the total surface area of the cuboid is 62 square centimeters. Form an equation in x. So now that's simple. We've already defined an expression. We've been given the other part, which is the equal sign. So now, very simple. We equate 14x plus 20 equals to 62. And since it's only 1 mark, no need to do anything fancy. 14x plus 20 equals to 62. You can factorize this or reduce to lowest terms, divide both all the numbers by 2. And then it will be 7x plus 10 is equals to 31. Okay, you can choose to bring like terms together, but it's not really necessary because you are going to do it in the next step. So you can bring like terms together and simplify, but you can simply leave it in the form 14x plus 20 equals to 62, or 7x plus 10 is equals to 31. Or you can do it and leave it in this way, 7x is equals to 21. It's still up to you. Right, moving on to the next part. It says solve the equation in B1 to find the value of x. So we said that 14x plus 20 is equals to 62. So now we simply move forward. We bring like terms together. 14x plus 20 minus 20 is equals to 62 minus 20. Why? Because whatever you do on the left side, you also do on the right side. So 14x is equals to 42. And then we divide both sides by 14 and 14. Divide 14 by 14, you get 1. And then divide the 42 by 14, you get 3. So our value for x is equals to 3. Okay? And that's it. You've solved the equation very simply. A solid object has a mass of 300 kilos and a volume of 2 cubic meters. Calculate the density of the object. To calculate density is equals to mass over volume. That's how we calculate density, mass over volume. So we just divide the given mass, 300 kilos, over the given volume, 2 cubic meters. Okay? So maybe some things to note there is that you can simply remember density as a ratio of mass with respect to volume. The volume, which is the cube of each of the sides. Okay, so I would say that the density can be thought of, to solve this problem, you can think of the density as a ratio of mass being proportional to the cube of the ratio of the length, which is simply just mass over volume. So without taking too much time explaining this, we're going to simply use the normal formula. Density is equals to mass over volume. And we're going to just simply calculate 300 kg over 2 cubic meters, and then get our volume, our density as 150 kilograms per cubic meter. The next question reads, a solid object has a mass of 300 kilograms and a volume of 2 cubic meters. Calculate the volume of a similar object given that the mass is 975 kg. In order to calculate this volume, we need to understand the ratio first. Since these are similar objects, the ratio of their masses is proportional to the cube of the ratio of their lengths. So what we simply do is we first calculate the density by using the direct mass to volume ratio, which we call density. So we find the density of the first object, in which we are going to get 150 kilograms per cubic meter. All right. So the mass is again 300 kilograms, and that volume is 2 cubic meters. To better remember, you can use these triangles to help you with these three relationships: density equals to mass over volume, volume equals to mass over density, and mass equals to density times volume. Since you want to look for volume, we can use mass over density. So the density, we can use the one we've already calculated it above there. So the density is equals to 300 kilograms over 2 cubic meters, which is going to give us 150 cubic meters. Okay. Then after we found that, we are going to calculate now using this volume equals to mass over density. The mass of the second object is 975. We use the density since these are similar objects. We use the same density to find the volume of the new object. So 975 over 150 is going to give us 6.5, or 6 remainder 75 over 150. And then this is the cubic meters. Then we reduce to the lowest term, 75 over 150 is same as 6.5 cubic meters, or we can leave it as a decimal, which is equals to 6.5 cubic meters. Okay, so remember, with similar objects, the ratios are supposed to be the same. So that is how we do it for that question. The next question reads, the diagram is a sketch of the graph y equals to x squared plus x minus 12. The graph cuts the y-axis at 0 and k. It crosses the x-axis at L and M. Write down the value of k. So you can see that from the graph there, the point at which the graph cuts the y-axis is the point at which there is k. So that k there is also called the y-intercept. From the graph, you can tell that the y-intercept is minus 12. Okay, so k is equals to minus 12. Now, after that, we are going to calculate the second part, which says find the distance between between those 2 points L and M, or find the distance of LM. So in order to find this, we need to find the distance of each of the individual points from the point of origin, O. So we need to find the distance of O to L and O to M. So to do this, we need to solve for x, okay, so that we find the distances from the origin. Then we add them together to find the absolute value. So that's very simple. We're going to, since on the x-axis the value of y is equals to 0, so we're going to equate our graph, or the equation of the graph, to 0. So y is equals to x squared plus x minus 12. We're going to equate it to 0 because on the x-axis the value of y is equals to 0. So 0 is equals to x squared plus x minus 12, or we can simply rewrite it as x squared plus x minus 12 equals to 0. And therefore our equation now can be solved using one of the 4 different methods which we can use to solve quadratic equations. Remember, if the highest power of the unknown is 2, the equation is called quadratic. If it is 3, it's called a cubic. But in this case, since the highest power of x is 2, this is a quadratic equation. We have, for our level, 4 different methods which we can use to calculate the unknown or solve for the unknown to find or to solve quadratic equations. We can use the factoring and regrouping method, which is the one that I will use. I find it quite simple if it is applicable. Okay, we can use the factoring and regrouping method. The second method which we can use is the quadratic formula. You need to remember all the terms and their various signs, if it is plus or minus. Then the next one is completing the square method. It is a more advanced method which requires you to be more thorough and technical, but it's a good method. And then the last method which you can use is simply by drawing a graph. So we don't need to draw another graph to solve another graph. It is unnecessary because we do not have enough time to do that. As well, we do not have the graph paper. This is just a sketch. So the best method, in my opinion, would be to use the factoring and regrouping method. So I'm going to adjust these quadratic solutions to one side so that I can continue on the left side here. Now, x squared plus x minus 12, we're going to use the factoring and regrouping method. Now, to use this method, it's very simple. We are going to find factors of minus 12 times 1, the coefficient of x squared. So it's just minus 12. We're going to find factors of minus 12, which are equal to positive 1, the coefficient of x. Okay? So if you want these details for this, of how to use this method, you can just check in the description. I've put my algebra playlist. You can check through the factoring or solving quadratic equations video. Now, the factors of minus 12 here, we've got minus 3 times 4 gives us minus 12. We've got minus 4 times positive 3. We've got minus 6 times positive 2. We have minus 2 times positive 6. We also have minus 1 times 12 and minus 12 times 1, but these ones are too far-fetched, so we just leave them alone. Now, we're going to add each of the pair of factors. Here, we're going to add minus 3 plus 4, and we're going to get here positive 1. Minus 4 plus 3, we're going to get minus 4 plus 3, we're going to get minus 1. Then we move on to minus 6 plus 2. This gives us minus 4, and minus 2 plus 6. This gives us positive 4. So you can tell here by just looking at these factors that the one which we want, which has got a number of 1, which is the implied coefficient before x there. So the factors that we want are factors which give us positive 1. In this case, it will be negative 3 and positive 4. So we're going to rewrite our coefficient of, or the number for x. We're going to rewrite x as minus 3x plus 4x, because if we add them, they just give us positive 1x. So we're going to have x squared minus 3x plus 4x minus 12 equals to 0. Then we can factorize here. We bring like terms together. We can see here that the first two terms, x squared and the minus 3x, have got some common factor between them, which is x. Then we factor out the x and remain with x minus 3. For x minus 12, have got a common factor, which is 4. Then we remain in the brackets with x minus 3, both equal to 0. Then we're going to take the common factor in both brackets, write it first, x minus 3, and then add the remaining factors, x plus 4 equals to 0. Now, when you have a product of two numbers giving you 0, it means that either one of these numbers should be equal to 0. So either the first bracket x minus 3 equals to 0 or x plus 4 equals to 0. So let's start with x minus 3. Either x minus 3 equals to 0, in which case x is equals to 3. Or x plus 4 is equals to 0, in which case x equals to minus 4. So the x value can either be positive 3 or negative 4. Now, since we've gotten these values, it's now simple to find the length of the line LM. It is the distance, the straight distance from minus 4 up to 3, or from 3 up to minus 4. That's very simple. We can just say 3 minus minus 4 giving us 7, or we can take only the absolute values, 3 and the absolute value 4, add them together, then we get our 7. Okay, that seems very simple. Otherwise, if you are not very sure, or if you just want to be extra careful, you could use a number line. On the extreme end, you've got minus 4. On the other end, you've got positive 3. Then you can simply count how many places you move to whichever side which you want. Only take the absolute value, disregard the direction. Why? Because you want the magnitude or size. So it's got nothing to do with the direction which you go. The size remains the same, 7 units. Let's move on to question 11. It is given that y is directly proportional to the square root of x. Given that x equals to 8 when y equals to 16, find the formula connecting x and y. So y is directly proportional to root of x. If we remove the proportionality sign, we replace with a k and put an equal sign. So y is equals to k root of x. Then we can use the given data to calculate the value of k. 16 is equals to k root of 8. Then we make k the subject of the formula by dividing both sides by root of 8. Root of 8. Then root of 8 cancels out each other on the right side. And on the left side, we're going to be left with k is equals to 16 over root 8. This is, of course, not the correct way to leave problems with square root sign. We call these ones surds. We need to rationalize the denominator to remove the surd part. So what we do is we're going to multiply by the root 8 for both the numerator and the denominator, so that we remove the square root sign in the denominator. This is what we call rationalizing a surd, or rationalizing the denominator. So it will be 16 root 8 over 8. If you multiply the square root of a number by the same square root of that number, you are going to get that number straight. So it's going to be 16 root 8 over 8. We divide 16 by 8, we get 2. So it will be 2 root 8. However, root 8 can be simplified further by saying root 8 is equal to root 4 times root 2. You can tell that root 8 has got a perfect square as one of its roots. So it will be y equals to 2 root 8 is equals to 2 times root 4 times root 2, which is equals to 2 times 2 times root 2, which is equals to 4 root 2. Okay. So here, y is equals to 4 root 2 times root of x. In which case now, we have two numbers which have got the square root sign. So the square root of a number x times the square root of another number y is the same as saying the square root of the two numbers x, y as a product. Okay, it's the same. So now our y will be y is equals to 4 root 2 x. That's the final value. Y is equals to 4 root 2 x. Okay. Then the next question says find the value of x when y equals to 12. So now we already have the value of y is equals to 4 root 2x. That's the formula connecting x and y that we found. Now we need to simply plug in the values to find x. So since we said y is equals to 4 root 2x, now we need to make x the subject of the formula by doing the following. First, we substitute the values which we've been given. 12 is equals to 4 root 2x. Then we divide both sides by 4, since 4 is a common factor there. So we're going to divide the right side by 4, then we divide the left side by 4. So 4 root 2x divided by 4, and 12 over 4 is going to give us 3 is equals to root 2x. When we get here, now we need to make x the subject of the formula. First, we need to remove the square root sign. So we square both sides. 3 squared is equals to 9. Then root 2x squared is equals to just 2x. Then we divide both sides by 2. Divide both sides by 2. And then our final answer is going to be x is equals to 4.5 or 4.5. Okay, so we found the value of x when y is equals to 12. All right. Moving on to question 12. Evaluate 1 over 3 to the power minus that one. So any number x to the power negative a is equals to 1 over x to the power of positive a. So here we've been given 1 over 3 to the power minus 2. So it is the same as 1 over 3 squared, okay, which is the same as 1 over 9, because 1 squared is 1, 3 squared is 9. Then we can rewrite this as 1 divided by 1 over 9, in which case we just invert when you divide by a fraction, is the same as multiplying by the inverse of that fraction, which is the same as 1 times 9 over 1, which is equals to 9. All right. So this there's a whole playlist of numbers you can check in the description to understand numbers better. The second part says 4 squared plus 4 to the power 0. Okay, so this one is very simple. 4 squared is 4 times 4. 4 to the power 0 is equals to 1. So this is equals to 16 plus 1, giving us a total of 17. Here, an important thing to note is that any number x to the power 0 gives you 1. This is where we got the 1 from when we said 4 to the power 0. Solve the equation. 5 to the power a minus 1 is equals to 1, 2, 5. So this one is quite simple. If you can see here that 125 looks like a multiple of 5. More correctly, it is a cube of 5. If you say 5 times 5 times 5 gives you 125. So now we have 5 to the power a minus 1 equals to 5 cubed. Now we know that in indices, if the base is the same, or if the base is equal, or if the bases are equal, then it must also mean that the indices are equal. That makes sense, right? If we say 5 to the power x is equals to 5 to the power 2, since the bases are the same, then it must also mean that the indices or the powers or the exponents, if you want, are also equal. So in this case, 5 is equals to 5, so therefore a minus 1 should be equal to 3. Then we rearrange, we add 1 to both sides. A minus 1 plus 1 equals to 3 plus 1, giving us a is equals to 4. So solve the equation, a is equals to 4. Normally when we are solving equations, we just need to find the value of the unknown. Right, 13a, factorize completely 5m squared minus 20. Firstly, we factor out the 5, which is common in both terms, 5 bracket m squared minus 4. Now you can tell that m squared minus 4 is a difference of 2 squares. This is a special factorization favorite, a difference of 2 squares. A difference of 2 squares is a number in which you can say one of that number is a plus b, then the other one is a minus b. Let's say if your original equation is a squared minus b squared, then the difference of 2 squares, when you factorize it, it's going to be a plus b bracket a minus b. So m squared minus 4 is the same as 5 bracket a plus b bracket a minus b. So we factorized it, breaking it down to its simplest factors, 5 bracket a plus b bracket a minus b. Next, we move on to part B, which says simplify 3x plus 3y divided by x squared minus y squared. This is, again, an interesting one. We factor out the 3 bracket x plus y divided by x squared minus y squared is, again, another difference of 2 squares. So if it's a difference of 2 squares, it means that we are simply going to have x plus y bracket x minus y. Now, you can tell that there's some commonality. There's x plus y in the numerator and denominator. You divide that, you cross it out, you're going to remain with 3 over x minus y. Next question, question number 14 says, the Table shows the number of children living in houses at the staff quarters at a certain school. So find the mode. The mode is the number which appears the most or which has got the highest frequency. Okay, this is what we call the mode. So how do you determine which one is the mode? The mode is that one number of houses. The number of children in the house is the value of n. So the number of children which has got the highest frequency is 3 because the frequency is 5. So the mode is 3 children per house. All right, 3 children in the house. Then the median is the middle number, given that after you arrange all the numbers in ascending order, there is an equal number of values, or there's an equal number of numbers on the left side of that median value and on the right side. So that's what we call the median. So in this case now, we can solve it using different methods. We can use the first one by simply looking at the numbers. We can tell that we have 15 houses with different numbers of children. 2 with 0, 3 with 1, 4 with 2, 5 with 3, 1 with 4, and 0 with 5. So what we simply do here is we just count the number of instances or the frequencies, the total number of frequencies. So it will give us a total of 15. Okay, 2 plus 3 plus 4 plus 5 plus 1 plus 0. So the total frequency is equals to 15. So the mid figure should be around 8. Should be 8 with 7 on the right and 7 on the left. So if we arrange this data in order, we are going to find that the 8th figure would be somewhere around 2. Why? Here we can simply use the cumulative numbers. Let's say, for example, if the mid number is 8, 2 plus 3 is equals to 5, and 5 plus 3 equals to 8. So within the next 4 numbers, that's where the 8 is. So it tallies with the number of children, which is equals to 2. Or we can simply use the odd method, or the more detailed method, in which we list the number of frequencies. We have 2 zeros, we have 3 ones, we have 4 twos, we have 5 threes, and we have 1 4 and 0 5s. Okay, so we list 0 0, 1 1 1, 2 2 2, 3 3 3, 3 3, and then we have again 5 4, just 1 4 and 0 5s. Okay, so the 8th figure there, or the 8th digit, would be 2 children. So the median is 2. Okay, then to find the mean, we simply multiply or find the total number of children divided by the number of houses, right? That's very simple. But what we're going to do, we're going to say 0 times 2 plus 1 times 3 plus 2 times 4 plus 3 times 5 plus 4 times 1 plus 5 times 0 divided by 15. Okay, and once we get that, then that will be our mean. So let's do that. So it's 0 times 2 plus 1 times 3 plus 2 times 4 plus 3 times 5 plus 4 times 1 plus 5 times 0, all divided by the total number of houses, which is equals to 15. Okay, so now 0 times 2 gives us 0. 1 times 2 gives us 2. Then 2 times 4, 1 times 3 gives us 3. 4 times 2, 8. 5 times 3, 15. 4 times 1, 4. 5 times 0, that's another 0. Then all divided by 15. Then we simply add 15 plus 8, that's 23, plus 3, 26, plus 4, 30. So that will be 30 over 15. And then we divide 30 by 15, we get 2. So our mean is 2 children, okay? 2 children per house, but just 2. Right, let's move on to question 15. In the diagram is triangle RST, MN is parallel to ST, RM is equals to that, RN is equals to that, and MS is equals to that. Name the triangle that is similar to triangle RST. So if 2 triangles are similar, then their internal angles are equal and the sides are proportional, okay? They're not equal, only the angles will be equal, but the sides are proportional, okay? So they've got the same shape, but they do not necessarily have the same sides. If they have the same sides, they're said to be congruent. In this case, RST is similar to RMN. So the ratio or and the order of their sides is also equal, RMN. The next part says find the length of NT. Okay, so if we are to look at our triangle there, we are going to get an idea of what we are supposed to do to get this length of NT. Firstly, we've been given that MN is parallel to ST, RM is equals to that, RN is that, and MS is equals to 10. And we've also determined that the triangle RST is similar to triangle RMN. Okay, so now to solve this problem of finding this distance NT, what we simply do now is find the ratio of the length of RMS to RS, and then use that to calculate the ratio also of RNS to NT. Okay, so here's what we are going to do to find this. We're going to use 2 methods. One method is the long one, the other one is the shortcut, okay, which is a lazy method. Firstly, I'm going to show you the tip. Since we can tell here, or which we've already determined, that the 2 triangles RST and RMN are identical, what we're going to do is we're going to use the properties of similar triangles to find the length of NT. So since RST and RMN are similar, it also means that their corresponding angles and their corresponding sides are also proportional, okay? So the corresponding sides are proportional, but the corresponding angles are equal, all right? Yes. The corresponding sides are proportional, the corresponding angles are equal. Having ascertained that, now we're going to do it in a series of steps, okay? So the first step that we're going to do is we need to find the total distance from R to T. So in this case, we need to find the total length, which is RS plus ST, okay? So once we find that total distance of RS, then we use it to calculate the distance NT. So total length of RS is equals to 5 centimeters, which is RM, then RM plus MS, all right? So this is 5 centimeters from R to M, and then M to S, that's 10 centimeters. So the total distance of RS is equals to 15 centimeters. Next, we use the property of similar triangles, all right? So this is the one that is going to help us to calculate the side that we want. So we're going to use the sides that we have to calculate the side that is missing on the side that we want, all right? So take heed and take note. The most important thing that you must note here is that for the lengths that you're going to use, or the sides which you're going to use, they must be corresponding in the order in which they occur on the 2 triangles. So if we said our triangle RST is similar to RMN, then it must also mean that RMS to RS is equals to RNS to RT. Why? Because the triangles are similar. All right. So now we just plug in the values. 5 over 15 is equals to 8 over RT. Okay. So you can already see where this is going, right? So to find RT, we make RT the subject of the formula. It will be the same as saying 8 times 15 over 5, which gives us 24 centimeters. So the total length RT, the total length RT is equals to 24. But what we are looking for is NT, okay? Since we already know that to get NT, we are going to say RT minus RN. RT we've already calculated, that's 24. And Rn we're already given, that's 8 centimeters. So to find NT, it's now simple. We subtract Rn from RT, 24 minus 8, giving us 16 centimeters. All right. Now, we can also use a lazier method, which I want to call the lazy method. Here you can already see that the ratio of 5:10 is 1:2 if you reduce it to its lowest terms, right? So you can already see where this is going. Yeah? If the ratio is 1:2 from R to M and then from M to T, then it must also mean that from M to S, from R to M and M to S, then it must also mean that from R to N and then from N to T should also be 1:2. So since it is already 8:X, then we simply multiply Rn times 2, or we can use an equation if you want to go the long way, of course. We can just simply construct an equation like we did last time. Rm over Ms is equals to Rn over Nt. All right. So in this case, it would be 1/2 divided by 8 over Nt. Once you do that, then it's simple. We just are just going to solve it like we did for the first time. So it will be 8 over 1/2 is equals to 8 over Nt, which is our x. Then to find x, to make x substitute formula, just x times 8 times 2, giving us again 16. So you can see that these two methods are just one and the same method. The other one has already been simplified. The other one is a bit more detailed and comprehensive, but it's basically the same thing. What I want you to notice is that you must know or remember to put the correct direction of the corresponding sides and the corresponding angles, so that you do not make mistakes in using or calculating the proportionalities. Question 16. It is given that the vector AB is equals to 3 minus 4 and the vector BC is equals to that. Express the vector AC as a column vector. So this is very simple. To find the vector AC, we simply say AC is equals to AB plus BC. All right. So now that's very simple. Now we plug in the values. 3 minus 4 plus 6 and 4. This one is simple. You add the corresponding values in the vectors. 3 plus 6 and minus 4 plus 4. Then 3 plus 6 gives us 9, minus 4 plus 4 gives us 0. Then our AC as a column vector is 9, 0. Part B, it says find the modulus of AB, which means find the absolute size of the vector AB. Remember, when you're looking for the modulus, you're looking for the value without paying attention to the direction. So since we have 3, 4, the formula for finding the modulus is you find the square root of 3 squared plus 4 minus 4 squared. Why are we squaring it? Because we only are interested in the magnitude, not the direction. All right. So square root of 9 plus 16 is equals to square root of 25. And then we're only going to take the positive root, which is positive 5. So this positive 5 is what we call the modulus of the vector AB. All right. So we take our modulus or the positive root of 25, which is equals to 5. As a tip, maybe so that you do not forget, I'm going to just highlight that you are only interested in the positive root, because if you include the negative, you are now paying attention to the direction, which is not correct. Let's say, for example, if we are measuring size of an object, it is a physical quantity. Quantities cannot be negative. They only have the absolute value, which is a positive value. You cannot say, I'm minus 10 years old. You're just 10 years old. You have the 10 years. It's a physical quantity which can be measured. So it has got an absolute value. This is why we do not take the negative root. All right. I hope that is clear there. All right. Having said this, now I think we can move on to the next question, which is the next question is going to be question number 17. Question 17A reads, convert 110,101 base 2 as a number in base 5. So what you can do here, the first thing is to convert to base 10. And then after you've converted to base 10, you then divide by 5 to convert to base 5. All right, that should be simple, right? All right, so let's start on this problem and see where we can get. Okay, so we have our number here, 110101 base 2, which is a number in base 2. So to convert to base 10, we're going to express this number as a product of the powers of 2. And we give the order of the magnitude of each of the numbers from the number immediately before the base. So 1 after the base there has got a value of 0, 2 to the power 0. Then the 0 has got 2 to the power 1, etc., etc., etc. So now it will reach up to 1 times 2 to the power 5 plus 1 times 2 to the power 4 plus 0 times 2 to the power 3 plus 1 times 2 to the power 2 plus 1 times 2 to the power 2 plus 0 times 2 to the power 1 plus 1 times 2 to the power 0. Okay, so make sure that you write the numbers correctly so that you avoid making errors, because once you make an error here on this expansion, the next thing that's going to happen is you're going to make an error in the number in base 10, and automatically it's an error carried forward. So here 2 to the power 5 is equals to 32, then 2 to the power 4 is equals to 16, 0 times 2 to the power 3 0, 2 to the power 2 4, 0 times 2 to the power 1 0, and 2 to the power 0 times 1 is 1. All right, 32 plus 16 plus 4 plus 1, 16 plus 4, that's 20, plus 32, 52 plus 1, 53. So this number gives you 53 base 10. Now, when we found 53 base 10, we are supposed to divide by 5 to get a number in base 5. Okay, so numbers in base 5, the highest number is 4, and yeah, that's like that. So we now divide 5 into 53, that's 10, remainder 3. 5 into 50, that's 2, remainder 0. 5 into 2, that's 0, remainder 2. We only stop when we've reached 0, and we record the remainders. And when we are reading the answer now, we are only going to take the remainders. So the remainders, we are going to read them from the bottom going up. So our answer would be 203 base 5. So this is how we find this number. You must have a lot of practice. Take time to practice a lot with number bases, converting from one base to another, solving or adding or subtracting numbers in the same base, and interchanging from base any base to base 10, etc., etc., etc. The second part B, arrange the following numbers in ascending order. So you've got a number in base 2, you've got another number in base 5, and another number in base 10. How do you solve this kind of problem? So to solve this one, you need to convert all the numbers to the same base. Either you convert all the numbers to base 2, all the numbers to base 5, or all the numbers to base 10. However, you'll notice that if you want to convert all these other numbers, like the numbers in base 2 and base 5 to base 10, you still need to pass through base 10. So like if you want to convert 1, 0, to from base 2 to base 5, you need to convert to base 10. And if you need to convert base 5 to base 2, you still need to pass through base 10. So the easiest would be, and most convenient, would just be to convert all numbers to base 10, then compare them. So let's convert all these numbers to base 10. 1, 1, 0, 1, 0, 1, 0 to base 2 to base 10. So the first is 0 there is 2 to the power 0. The next one is 2 to the power 1, 0 to the power 2, 1, 2 to the power 3, and the other one 2 to the power 4. So what we will do is we're going to expand it. So it will be 1 times 2 to the power 4 plus 1 times 2 to the power 3 plus 0 times 2 to the power 2 plus 1 times 2 to the power 1 plus 0 times 2 to the power 0. Having expanded, now we need to write the values. 2 to the power 4, that's 16. 2 to the power 3, that's 8. 0 times 2 to the power 1. 2 to the power 2, that's 0. 1 times 2 to the power 1, that's 2. 0 times 2 to the power 0, that's 0. So that's 16 plus 8, 24 plus 2, 26 base 10. Then we look at the other one, 3, 1, 2 base 5. To convert to base 10, we do the same way. 2 is 5 to the power 0, 1 is 5 to the power 1, and 3 is 5 to the power 2. So 3 times 5 to the power 2 plus 1 times 5 to the power 1 plus 2 times 5 to the power 0. So 5 squared, that's 25 plus times 3, that's 3 times 25 plus 5 plus 5 to the power 0, that's 1 times 2, that's 2. Then that's 75 plus 5, that's plus 2, 82 base 10. Now these are all easy to compare. We have 26 base 10, 82 base 10, and 13 base 10. So in ascending order, starting with the smallest, that's 13 base 10, then 1, 1, 0, 1, 0 base 2, then finally the largest is 82 base 10. That's very simple, right? Then the next part now asks us to perform some operations with numbers in the same base. All right. So we have two methods that we can use. When we are given an equation like this, evaluate 312 base 5 minus 143 base 5. What we can do, we can use one of two methods. We can simply subtract them in the same base like this using some special techniques, or we can convert them to base 10, both of them, subtract, then reconvert back to base 5. Let's start with the first one. 312 minus 143 base 5. So what we do now is we are going to use the borrowing method, which we use in normally add or subtract, but we are going to add some tweaks here and there. Right, so 2 minus 3 is impossible. So we need to borrow 1. Since 1 or 1 or is equals to 5, when we add the 5 to the 2, it gets to be 7. Now it is easier to subtract, so we say 7 minus 3 gives us 4. But since we borrowed, we return the 1 to the number that we borrowed there. So instead of being 4, we add a 1 there, that becomes 5. But since we are in base 5, the highest number in base 5 is 4. So that 5, we're going to divide 5 divided by 5, which is going to be 1 remainder 0. So we put a 0 there. and add the 1 to the 2 on the other number, so that we can subtract better there. 1 minus 0 gives us 1, and 3 minus 2 gives us 1. So our answer there is 114 base 5. Or we can take the other method that I gave, where we convert both of the two numbers to base 10. After we've converted both of them to base 10, then we operate them normally like we do, and then after we finish, we reconvert back to base 5 by dividing the answer only by 5. So we need to convert 312 base 5 to base 10 and 143 base 5 to base 10. So let's start that. These tips that I'm writing, they're important. If you have got a notebook, just jot them down somewhere when you're doing your revision. If you're using your past paper, just jot these questions down so that you can, go through them another time when you have time, and also that they help you in your practice and revision as you prepare for your upcoming exams. So the best thing with mathematics always is that you have a lot of practice and a lot of revision so that you don't forget. There are a lot of concepts. So these concepts need constant practice so that they don't evaporate from your mind or from your fingertips. You need to keep these tips and tricks and the exercises always with you at your fingertips. Again, we use the same method that we used to convert to base 10. 3 times 5 to the power 2 plus 1 times 5 to the power 1 plus 2 times 5 to the power 0. And that's going to give us a certain number. Then again, we subtract we subtract 1 times 5 to the power 2 plus 4 times 5 to the power 1 plus 3 times 5 to the power 0. This will give you 75 plus 5 plus 2, subtracting 25 plus 20 plus 3. And we again simplify. That's 82 minus 25 plus 20, that's 45 plus 3, 48. 82 minus 48, both in base 10. So 82 minus 48, that's a simple operation. 2 minus 8, that's going to give you a 4. And then 8 minus 5, that's going to give you a 3. And then after this, you now need to convert back to base 5 by dividing 34 base 10 by 5. Okay, so 34 base 10 by 5 into 34, that's 6, remainder 4. Then we divide 6 by 5, that's 1, remainder 1. And we record all the remainders. Then we divide 1 divided by 5, that's 0, remainder 1. Again, we read from bottom going up, we still get to the same answer, 114 base 5. So a lot of practice is going to save you a lot of time and stress in the exam. So be prepared so that you do not get embarrassed or ashamed, okay? I read somewhere that a workman who is prepared is not ashamed. The scale on a map is given as 1 is to 150,000. Find the distance on the ground represented by 1 centimeter on the map and give the answer in kilometers. So what this means is 1 centimeter is representing 150,000 centimeters on the actual ground. So if 1 centimeter on the map represents 150,000 centimeters on the ground, we now need to calculate to find how many kilometers are in 150,000 centimeters. So we can do the long way of first dividing 150,000 centimeters by 100 to find the number of meters, which is 1,500 meters. Then we divide by 1,000 to get the number of kilometers, since there are 1,000 kilometers in a kilometer. The other simpler method is to just divide by 100,000, because that's the straight conversion from centimeters to kilometers. since they're 100 centimeters in a meter and 1,000 kilometers in a 1,000 meters in a kilometer. So the straight conversion would just be divided by 100,000 and we still get 1.5. Part B, calculate the distance on the map representing a distance on the ground of 7.5 kilometers and give your answer in centimeters. So the distance on the ground is 7.5 kilometers. Now we need to calculate the distance on the map. Again, we can use two methods. We can simply just divide by 1.5 kilometers since we've already determined that 1 centimeter on the map represents 1.5 kilometers on the ground. So we can simply divide 7.5 kilometers over 1.5 kilometers. Or we can say convert 7.5 kilometers to centimeters, which would give us 750,000 centimeters. And then we divide by 150,000. Then we are going to get 75 over 15, which is the same as 7.5 over 1.5, which is simply 5. So our answer in centimeters would be equal to 5 centimeters. Okay. And part C says calculate the actual area represented by an area of 4 square centimeters on the map and give the answer in square kilometers. So here we need to just use a trick. We can see that 4 square centimeters means that it's 4 centimeters times 1 centimeter times 1 centimeter. Okay, that's how we can break down 4 square centimeters. A square centimeter is 1 centimeter by 1 centimeter. Now, if we are having an area of 4 square centimeters on the map, it means that we are going to multiply that 4 multiplied by 1 centimeter. We said on the ground it's going to be representing 1.5 kilometers. Okay, so it will be 4 times 1.5 kilometers times 1.5 kilometers. Or you could simply say 4 times 1.5 squared. Okay, it will be the same thing. So if we calculate 1.5 times 1.5, obviously we are not using a calculator in this paper. 1.5 times 1.5 is the same as 1.5 times 1.5, or 3 over 2 times 3 over 2, which gives us 9 over 4. And if you multiply by 4, that gives us 9. Or we can divide 1.5 times 1.5, the long way gives us 2.25. Then we multiply 2.25 kilometers squared times 4. It will again give us the same number, 9. Okay, so 2.25 times 4, that's 9. So in the actual area represented by an area of 4 square centimeters on the map would be 9 square kilometers on the actual ground. This is the true conversion where it will lead you after you've completely calculated the answer. I want you to take note that if you are doing these scale problems, you must notice that if you are just using linear scale, then the scale factor is just multiplied once. When you now convert or move to doing area, the scale factor is now squared. Okay, why? Because you are going to use it in multiplying maybe the length, then multiplying by the width as well. So this is why I had to express my number like this. I put it in such a way that after we've done this, I can explain and then it can make sense, so that next time when you are working with area problems which involve scale, you just need to square the scale factor, then multiply by the number which you are using. All right, let's move on to write the correct answer on the given space. That's 9 square kilometers. Then move on to question 19. It says here, it is given that A is equals to K bracket that. Express M in terms of those two numbers. What you must do here is, firstly, we copy out the formula. A is equals to H bracket 4M plus H. Then we need to make M the subject of the formula. So let's expand first. A is equals to 4MH or HM plus H squared. Then we subtract H squared from both sides. A minus H squared is equals to HM, 4HM. All right. Then next we divide by 4h so that we can have the m as a standalone figure or expression or term. All right, that's the more correct term. To have m as the only term on the right. So we divide by 4h both sides, 4h on the right, 4h on the left. So once we divide that, on the right side we're only going to be left with m, and on the left side we're going to be left with a minus h squared over 4h. So finally our answer will read as m is equals to a minus h squared all divided by 4h. Okay, so just watch out when you are doing these kinds of problems. If you've got any challenges, just check out one of the videos that I already put in the description below. Given that a is equals to 20 and h is equals to 2, calculate the value of m. So now we just need to plug in values. We've already ascertained that the rearranged or the expression which now has m as the subject of the formula reads m is equals to a minus h squared over 4m. Now, after we've redone this, then simply what we need to do is to plug in the correct values to find the value of the unknown that we are looking for. So here, a is equals to 20, so m is equals to 20, minus h is equals to 2, so 2 squared, that's equals to 4, and then 4 times h, or 4 times 2. Next, we simplify further. 20 minus 4 over 8. 20 minus 4, that's 16 over 8, which gives us 2. So our final answer there would be equal to 2. Right, let's move on to question 20. The diagram shows points A, B, C, and D on the circumference of a circle center O. The line BS is a tangent to the circle at B, and this is produced such that it meets the tangent from B at S, and DAC, which is the angle at A there between D and C, is close to 42 degrees. Find OBC. Okay, OBC is that angle there. Now, when you are given a question like this, you must use all the knowledge that you have about geometry from all the studies that you've done in geometry. Remember all those rules and theorems that you've done and use them to help you calculate the wanted value here. If we take that diameter there passing through O, we can tell that we know that all the triangles which are subtended at the circumference with one of their sides being the diameter, you have got an angle at the circumference of 90 degrees. All right, so 42 degrees of DAC is part of the 92 degrees of the 90 degrees. So if we subtract 42 from 90, we're going to get 48 as one of those angles there. In essence, what this means is if DAB is equals to 90 degrees, then our angle CAB is part of that 90. Then angle CAB is equals to 90 degrees minus 42, and this gives us 48 degrees. Okay, so 48 degrees represents that angle CAB, and now we're going to use other theorems from our previous studies. You can also tell that this quadrilateral its vertices are inside or are touching the circumference of that circle, and hence this makes this shape a cyclic quadrilateral. Okay, so now we're going to employ the rules of cyclic quadrilaterals, of tangents and segments, because all of them now have been employed there. All right, So now to find OBC, now we're going to use the angles in the same segment. Okay, so we're going to take our chord DC, which divides the circle into two segments, the major segment and the minor segment. So these angles will be in the same major segment. And we know that angles in the same segment are equal if they are formed from the same chord there. All right. So we have our angle formed at DAC, and then our other angle formed at DBC. Because they are all formed from the same chord DC and they're all in the same segment, it must imply that angle DAC is equals to angle DBC, which is also the same as angle OBC. Okay, so this is our chord DC that I'm talking about, and I'm going to highlight it so that it's easier to see. So this chord has got that triangle, and this angle is 42 degrees, and also has this other triangle. So these angles, because they are in the same chord, it must mean that they are equal. So that angle there, OBC, should also be equal to 42 degrees. Remember what I said earlier on, when we are doing geometry and we find a side or an angle, we must justify why. We write the justification. So it's 42 degrees because there are angles in the same segment, or you can just write chord, but it's the same as saying in the same segment. Right, then next we are going to calculate another angle. If you remember well, that angle there, you should know from the other theorems, when a tangent meet a circle at a point, the line which passes from that point at which the tangent meets the angle, the circle, going to the circumference, it forms a 90-degree angle. So that angle there, OBC, which we said is 42, the other angle outside it, that a small exterior angle of angle OBC, should be equal to 48 degrees because it is outside of that. It is part of the 90-degree angle formed by when the tangent meets the circle, and this OB is a radius. Okay, so that's another rule if you're going to observe. So that angle there, CBS, should be also equal to 48 degrees. So here we're going to just write the answer 42 degrees in the space that we've been given. Then we move on to do the next one, CAB. We go back to our diagram. CAB, we've already calculated it. We found that CAB is equals to 48 degrees. Why? Because it is part of the 90-degree angle formed from that triangle which is subtended at the circumference by the diameter. So that angle is 48 degrees, and we justify because we say that it's an angle subtended from or subtended at the circumference of a triangle which has got one of its sides as the diameter. Okay, then we need to calculate DSB. Okay, so to calculate DSB, we can use many theorems. Since we've already ascertained that that angle is 48 degrees, we also know that segment theorem and determine this angle here. Since this angle, which is formed outside there, is part of a triangle that has been formed, which has got one of its sides as the diameter. So the angle at C of DBC or DCB there is 90 degrees. So it also means that the other angle outside there is 90 degrees. And since we know that the angle sum of the angles of a triangle is 180 degrees, then it must mean that 180 minus 90 minus the 48 that we've calculated makes the angle DSB equals to 42 degrees. Okay, so this is how we can solve this triangle. DSB there is equals to 42 degrees. We can use the angle sum of the triangle. We can use angles subtended by the same chord, or angles in the same segment, or we can use the theorem or a combination of theorems, that one of the tangent. We can also use the alternative segment theorem, and we'll still arrive at the same answer of 42 degrees for that angle there of DSB. All right, so here I'm just going to record the angle sum of the triangle after we've worked out some of those angles. Let's move on to question 21. The diagram shows 3 towns, P, Q, and R on level ground. R is equidistant from P and Q, and the bearing of R from P is 125 degrees. QPR is 68, so we also know that angle at Q there is equals to 68. Since we've been told that it's equidistant, it also means that that triangle there is an isosceles triangle. Now, having done that, we are going to look at the question, which requires us to make some computations. Firstly, asks us to find the angle at R there, that angle PRS. Okay, so since we've already determined that the other angle is 68, we simply say 180 minus 68 plus 68 in brackets, which is 180 minus 136. 8 plus 8, that's 16. 6 plus 6, 12 plus 1, 13. So 180 minus 136 gives us 44 degrees. So the angle PRS is equals to 44 degrees. All right. So all your working should be done in the spaces provided. Don't just have magical answers coming in the answer space. So always put working so that whoever is marking can follow through your reasoning and your logic. All right. After that, we are going to move on to the other part to calculate the bearing of town P from town R. So we've already been told that the angle there for town R from P is 125. Now here we can use a lot of reasonings or logic from geometry and bearing. However, the simpler one is to use this one, where we can tell that this, if we protrude the angle directly north from R, we can get sort of like a U shape and form what we call co-interior angles. Now, from co-interior angles, we know that they add up to 180 degrees. So if one of the angles is 125, then it means that the other co-interior angle is equals to 180 minus 125 degrees, which gives us 55 degrees. So that small angle there, which I have marked X, is equals to 55 degrees, since 180 minus 125 is equals to 55, right? Now, this is not the end of the question. The bearing is always calculated from north in a clockwise direction and given as a 3-figure bearing. So P from R starting from north is simple as just saying 360 degrees, which is a full revolution, minus only that small part which we do not want, 55, and this gives us 305 degrees. So the angle or the bearing of P from R is equals to 305 degrees, because we've subtracted that 55 degree angle from the 360 degree revolution, and that kind of gets us to where we want to go. Okay, so don't forget to put your working. It is always important to put working. Firstly, we said the first part of the working which you need to put is 180 minus 125, which gives you 55. Then 360 degrees minus 55 gives you 305. That's the answer there. Then the next part says calculate the bearing of P from Q. P from Q. Right, you can tell from the diagram there that it's going to be a bit complex, but no need. Let's draw again this true north, and then we need to calculate that angle there. Let's call it Y, okay? Again, we're going to form co-interior angles there, and we can also tell that there is some relationship which we need to work out here. So what we can do is to find the total angles from the bearing of Q from P, which is 125 plus 68. That gives us a number like 193. Then we subtract 193 from 360 to get 167. Then we use again, now we know that that out exterior angle there would be equal to 167. Then we use that co-interior angle theorem, because we know that co-interior angles add up to 180. Then it would be just 180 minus 167, giving us 13. We can also use an alternative method, which of course I wouldn't highly recommend, but it's another one which you can use. Since we've already found out that 125 plus 168 is equals to 193, right? What we'll simply do is we're going to say the bearing of Q from P, we've already determined it's 125 plus 68, giving us 193. 8 plus 5, that's 13. 6 plus 2, 8 plus 1, that gives us a 9. And then 1 plus 0, giving us just a 1. So Q from P would be equal to 193 degrees. Now what you can also do here is, since that other angle is inside there, we can simply subtract 180 from that. Of course, this is not a conventional method. I wouldn't highly recommend. So it would be 193 minus that angle, that 180, and then what we'll get now is our angle, the same angle again, 13. But I would highly recommend that you use the first method so that you do not have problems in remembering that method, since of course you may face challenges. Again, remember that three-figure grid reference for bearing is always given as three-figure reference, so we need to put a 0 before the 1, so it becomes 013 degrees. So the bearing there would be equal to 013 degrees. So then you now just need to write your answer in the given space. Moving on to question 22. Question 22 says, given that 4p minus 2 bracket 3 1.5 minus 6 0 equals to p, find the matrix P in the form A, B, C, D, where A, B, C, and D are numbers. All right, so let's put that down in writing. You've been given that 4p minus, you're going to have that scalar 2 multiply every term in the brackets in the matrix. So 2 times 3 gives you 6, 2 times 1.5 gives you 3, 2 times minus 6 gives you minus 12, and then 2 times 0 gives you 0. Okay, and then you close your bracket. So you've been given that 4 minus p, this one, which when you expand it gives you 6, 3, minus 12, and 0 is equals to p. Okay, so now you need to rearrange, bring like terms together so that you can work this one out nicely. So 4p minus p, you bring p to the left side, then minus the matrix, you take it to the right side. The minus sign goes, now it's positive, is equals to 6, 3, minus 12, and 0. All right, so now we close your bracket, obviously, to show that it's a matrix 2 by 2. So 3p is equals to 6, 3, minus 12, 0. To find p, the matrix P, you divide both sides by 3, or you multiply by 1 over 3. Then we are going to get P is equals to, the scalar is going to multiply every term in the in the matrix. So 1 over 3 times 6 gives us 2. 1 over 3 times 3 gives us 1. 1 over 3 times minus 12 gives us minus 4. 1 over 3 times 0 gives us 0. So that means our matrix P is equals to 2, 1, minus 4, 0. And therefore, A is equals to 2, B is equals to 1, C equals to minus 4, and D is equals to 0. All right? Fine. Let's move on to part B of our problem. Right. Now, after you've written your answers here, you are asked now to find the inverse of the matrix. Now, to be able to find the inverse of a matrix, you first need to determine if the matrix is invertible. Okay, so to check if an inverse can be found of a particular matrix, for example, in this case, matrix P, you need to find what we call a determinant. If the determinant is not equal to 0, then the matrix has got an inverse. Okay, so you now need to find the determinant of the matrix P. So to check the inverse, if the inverse can be found, first find the determinant of P which is not equal to 0. Okay, so how do we find the inverse of a matrix? Let's go to find the determinant. How do you find the determinant of a matrix? The determinant of a matrix can be found by saying AD minus BC. Since we've named the individual figures there in the matrix A, B, C, D, so A is equals to 2, B is equals to 1, C minus 4, D 0. Then we just multiply A times D, then we subtract B times C. So our A is 2 times 0, which is D, subtract minus 1 times minus 4, which is 0 plus 4, giving us 0 minus 4, or 0 plus 4, right? Giving us 4. And therefore, since our determinant here is equals to 4, it's greater than 0 and not equal to 0, it therefore means that this matrix P has got an inverse. Yay, right? Now, let's go on to calculate the inverse of the matrix P. How do we calculate the inverse of matrix P? To calculate the inverse of matrix P, we say 1 over the determinant multiplied by A and D inverted and B and C multiplied by minus 1. Okay, so let's put that in writing. So the inverse of P can also be written as P to the power minus 1, which is equals to 1 over determinant of P multiplied by the inverted matrix, or the inverse matrix D minus B minus C and then A. And then we are going to say 1 over our determinant. We've already calculated it's 4. So it's 1 over 4 multiplied by we have our matrix which has been we already found out the values of A, B, C, and D. So now we just need to plug in the values there. D is 0. B is 1 times minus 1 is minus 1. C is minus 4 multiplied by minus 1, that gives us 4. And then A is 2. So this is our final form of the inverted matrix. Question 23 is a set problem. On the Venn diagram, draw or shade the set A intersection B in brackets union C. So firstly, A intersection B is the whole area there that I've shaded in blue. And then A intersection B unioning with C, meaning that all the elements of set C are supposed to be there. So the part of C that's in the A intersection, also the other part of C that's also intersecting with A, and the other part intersecting with B, all are to be there. So this whole shaded region with green and blue is the region A intersection B in brackets union C. Okay, Then we move on to part B. In a class of 45 children, 30 do agriculture, 25 do computers, 7 do neither agriculture nor computers, meaning that they are complement of A and C. Find the number of children who do agriculture only. The best way is to draw a Venn diagram. So here's the mother set. It is got subsets A for agriculture and C for computers. So A there and C here. So in A, there are 30 who do agriculture only, and in C, there are 25 who do computers, including those who also do agriculture and computers, which are in the intersection. So let A intersection C equals to X. So those who do agriculture only will be 30 minus X. And those who do computers only will be 25 minus X. And then there are 7 who do neither agriculture nor computers. That's 7. We put them in the universal set, but outside of sets A and C. Now, we need to formulate an equation to find the value of X so that we may be able to determine those ones who do agriculture only and those ones who do computers only. So what we do, we subtract X from sets A and C to have this equation 30 minus X plus the X in the intersection plus 25 minus X plus 7 equals to 45. So why we're subtracting the X so that we can get those ones who do agriculture only. So this becomes 30. We'll bring like terms together, 30 plus 25 plus 7 plus minus X plus X minus X, which just gives us minus X. 30 plus 25 plus 7 gives us 62 minus X equals to 45. Then we bring like terms together again. 62 minus 45 is equals to X. Then what we are going to get here is, well, let me write it on this side here. 62 minus 45, we will get 17. So X is equals to 17. Now, it means that in the intersection A intersection C, which we said is equal to X, is going to be represented by 17. So A only is 30 minus 17, which is equals to 13. X is equals to 17, like we calculated, and 25 minus 13 is equals to 8. Okay, so that's it. So the number of children who do agriculture only is equals to 13 minus 17, which is equals to 13. All right, let's move on to the next question. We're almost done with our paper now. Question 24. I think this is the last question. We are given a diagram which shows a speed time graph of a moving object. The starting speed is 50 meters per second. The deceleration is 4 meters per second squared for the first 5 seconds. Then it maintains constant speed for the next 20 seconds. Then part A says, calculate the speed of the object when time is 10 seconds. Normally you would get a question where it asks you, calculate the speed at 5 seconds, but you can tell that from 5 up to 20, the speed is the same. It's at constant speed for the next 20 seconds from 5 seconds. So since the speed is the same, you can put the V1 or V as the final speed. The starting speed, we can put U or V0. And then the deceleration, we can represent it. You know that deceleration is equals to negative acceleration. So we can say that the acceleration is equals to minus 4. Okay, so now we want to calculate the final speed. We've been given the initial speed, which is 50. The final speed we do not know. We say it's called V or V1, depending on the equation which we will use. And then the acceleration is negative because it is decelerating. And the time is 5 seconds. So calculate the speed of the object when t is equals to 10 seconds. So the speed when t is equals to 10 seconds is the same speed when t is equals to 5. So we can use this equation. Let's first put what we have. T is equals to 5. Then we also write down the other values which we have. Acceleration equals to minus 4. And V1 we do not know, but V0 or U, initial velocity, is equals to 50. So we use this equation, v is equals to u plus at, where v is the final velocity or speed, u is the initial velocity or speed, a is acceleration, and t is the time. So v is equals to u plus at, v is equals to 50 plus a is negative minus 4 times 5t. So 50 minus 20 gives us 30 meters per second. It's a very simple, right? Or if this one is difficult to remember, we can also use another one, another motion equation, where we use acceleration is equals to change in speed divided by change in time, which is delta t. So a is equals to delta v, which represents change in velocity or speed, over delta t, change in time in seconds. So we're going to say acceleration minus 4 is equals to change in speed v final, which is v1 or just v2, minus initial velocity, which is u or v0. So if you put v2 here, we should put v1 there, over final time t2 minus t1, which is 5 minus 0 there. Right, then v2 we do not know, that's the one that we're calculating. V1 is equals to 50, then time 5 minus 0 is just 5. So minus 4 is equals to v2 minus 50 over 5. Then we multiply both sides by 5 to remove the fraction part. Then we're going to get minus 20 is equals to v2 minus 50. Again, you can see that it's an alternative form of that version of v is equals to u plus at, and we're going to get the same answer. Minus 20 is equals to v2 minus 50. Then we take 50 to the other side, minus 50 is going to become 50. 50 minus 20 goes to 30, which is equals to v2, and we get the same answer there. Maybe something just worth noting is that whenever you encounter acceleration and deceleration, you should always remember that they are the same thing but going in opposite directions. When it is just acceleration, you are given that the acceleration is mostly positive. But when you are given deceleration is negative acceleration. This is why you saw that I used the value of minus 4, but I used the word acceleration. So if you choose to use the word acceleration for a sloping graph, which is sloping downwards to the right, it is deceleration, and you need to put a negative sign. But if it is increasing to the right, it is positive, and then it is just acceleration. When speed changes in the positive direction towards the right, then it is positive acceleration. Just remember that acceleration only is positive, deceleration is negative acceleration. Okay? All right. So that's just one thing that I wanted us to put out of the way. Right, so let's move on to the last part. We are supposed to calculate the total distance moved. So to calculate the total distance moved, we need to find the area under the graph. To find the area under the graph, we can divide the shape into different shapes. We can divide it into a trapezium and a rectangle if we want, and then use the formula for calculating area of a trapezium and area of a rectangle. Or we can divide it into a rectangle and a triangle. Since we've already determined that this point of constant speed is equals to 30. Okay, so what we simply do here is we are going to calculate the area under this rectangle and then add the area of the triangle. So we've already ascertained that the constant speed is 30. So our value there will be 30. I prefer this one. This method is much faster and simpler and more direct. So let's use the area of a rectangle, that one, 25 times 30, plus area of a triangle, half base times height. So area of rectangle is 25 times 30, which we've already calculated, and this gives us 750 meters. Then we also need to calculate the area of the triangle. The area of the triangle is half base times height. So we're going to say from 30 to 50, that's 20. and then from 0 to 5, that's just 5. So the area of the triangle is going to be 20 times 5 divided by 2, or half of 20 times 5, which is 20 times 5 gives us 100, and 100 divided by 2 gives us 50 meters. Okay, so now we have 50 meters and 750 meters. Now we just need to add the total area is equals to area of rectangle plus area of triangle, which is equals to 750 meters plus 50 meters. So that's 750 meters plus just the 50 meters of the area of the triangle. Now 750 plus 50 gives us 800. All right. So now we've calculated the area. We found that it is 750 plus 50, which gives us 800. And this now becomes our total distance. So the distance moved is the area under the graph, which is found by calculating the areas of the different shapes there. So distance, to put it in writing, distance equals to area of rectangle plus area of triangle. Then area of rectangle, its length times width, which is 750, which is equals to 25 times 30, and then area of triangle is equals to 20 times 5 divided by 2. So those will be the two areas, so that you can put your working when you are showing working. Remember that you must always show working. If you do not show working, you may lose part marks, because some answers are dependent on the marks, on the working. If you don't show working, you lose. So 750 meters plus 50 meters equals to 800 meters. Now this marks the end of our paper. Hope you enjoyed it. Check out this paper 2, which is shown on the links on the screen. Remember to subscribe and like and comment if you've got any questions or any section which you do not understand. See you in the next paper.